Okay, so let's have a look at this problem. So graph of velocity of 100 meters sprinter throughout the 10 seconds. So this whole thing took 10 seconds. That it took him to run his race is shown in figure 1. Assume the sprinter ran in a straight line. So this whole thing took 10 seconds. And this is velocity versus a distance graph. So this is actually quite unusual. Usually you get usually you have velocity versus time graph where the area underneath gives you the displacement and the gradient in VT graph gives you the gradient gives you the acceleration, right? And in displacement versus time graph, you have the gradient gives you the velocity. Okay. So those are the usual sort of kinematics, the graphs that you would get in usual normal kinematics problem, but this is actually quite unusual. So you have velocity versus distance. And these are the equation of motion. I think we went through that in the previous lecture, equation of motion. And one equation that's missing from here is S is equal to the average velocity times by time, right? Let's have a look at question 36. So in this question, you don't need any of these equations. So let's have a look. So the best of the following estimates of the time that the runner took to run the final 50 meters. All right, so the final 50 meters is from there to there. So from there to there, all right? And you can see that the distance is 50 meters, and you can see that the velocity at the start of the second half of the race is 12 meters per second. And by the time this one finishes the race, it's about, so this is about 11 right there. So this is about 11.5, right? So this is 12. So initial velocity is 12, and the final velocity is 11.5. So we can think that the average velocity is around, so the u plus v over 2 equals to 11.75 meters per second. Okay, so you can see that so the answer would be, so time taken is 50 meters, divide that by 11.75 meters per second, then you would get the answer. Okay, but of course you're not allowed to use a calculator, so we have to get the estimate of this. Okay, so imagine if you have 50 divided by 50 meters, let's suppose that you ran this at 10 meters per second, then that would take 5 seconds, right? So obviously the 5 seconds is not the answer because our average velocity was not 10, it was 11.75. Let's divide, if you know a bit of maths, then you would know that 50 divided by 12.5, that gives us 4 seconds. We didn't run at 12.5, we ran at 11.75, so that can eliminate 4 as well. Now the question is, you can see that 11.75, if you think about it, is actually closer to 12.5 than 10. So the answer is something that is closer to 4 than closer to 5. So the answer is definitely 4.3. So that's how you get the answer. 37. So best of the following estimates of the average acceleration of the runner over the first 15 meters. So first 50 meters is from there to there. So let's mark that point there. So that's about 9 meters per second. So initially when it started, of course it starts from 0 meters. Its velocity was 0. But when it gets to about 15 meters, you can see that this is constantly increasing its velocity there. You can see that velocity is increasing. By the time it gets to about 15, the velocity is 9. So we don't, in this question here, we don't have any clue about how long it took, you know. And I told you in my first lecture that if you don't know time, your best guess, your best bet is this equation right here. So it doesn't have any time involved, right? So this one gives you v squared equals to, all right, I'm moving out of the zone, so v squared u squared plus 2as. And we know that the s is equal to 15. It ran 15 meters, right? And the final velocity is how much was it? Like 9, that's right, 9 meters per second, and initial velocity is equal to 0. So if we plug that all in, this is equal to 81, 9 square 81, and 0 square is 0, and 2as, which is 2 times by 8 times by 15. So this gives us 30a equals to 81. So 81 divided by 30 equals to a. So acceleration is given by 81 over 30. So we can see that 81 over 30 is definitely more than 2, right? So 81 can, at least 2 30s can fit into 81. So you can see that's about 2 point something, So that's why the answer is D there. Okay, now let's have a look at this question here. The graph that best represents the distance versus time graph for the runner is. So we have to translate this into distance versus time graph. All right, let's have a look. So you can see that from these two equations, it says, we worked out that the final distance, final 50 meters, is covered in about 4.3 seconds. So you need to get this question right in order to get this question right. So they're all sort of bundled together. So if you get one question wrong, there is a very high chance that you get the rest of the questions wrong. So we can see that for the final 50 meters is right there. So that's 50 meters there and 50 meters there. So if we actually put a line through like this, okay, it says that from 50 meters to 100 meters, it took about, from there it's about 3 seconds to 10 seconds. That means it's taking about 7 seconds, right? So that's not likely. That's not true. So if you draw a line here and then go down this way, you can see that this is 50 meters to 100 meters is from there to there, but it's taking 1, 2, 3, 4, 5.5 seconds, right? So this is also wrong. So that's about 5.5. And you can draw a line here and you can see it's about there, and that's about 4.3, isn't it? 1, 2, 3, 4, and 0.3. So this looks reasonable. All right, so we cross this one out, and we go this way here as well, and then you go down this way. This is about 1, 2, 3, 4, and 4.3 seconds. So I think this is reasonable as well. Now, next thing you can look at to distinguish between those two is, you can see that the distance is, you can see that the gradient, what did I tell you about the gradient in distance versus time graph? That is equal to the velocity. So you can see that here, velocity is suddenly like rising. You can see that the gradient is like sort of getting steep, and then, so it initially gets steep and then decreases, right? So velocity initially increases and decreases. Here, gradient is sort of steady, right? Well, we see that over here, gradient is roughly steady. You can see that it's about 12. It doesn't suddenly increase its velocity. It doesn't do that at all. It just maintains about 12 meters per second to about, this is 11.5. So I think this is a better bet than this one, because there isn't much fluctuation in the velocity, so there shouldn't be much fluctuation in the velocity. Another thing you can think of is within, let's have a look. So this is about 20 meters here. This is about, so we can actually come back to this one. So when we actually do this question, it will make more sense. So it says 20 meters there. So how long did it take for the runner to go for 20 meters? So you can actually, if you actually get this question right, let's say you went for C, then you would know it takes about 3.5 seconds, right? If you went for this choice here, then you would go for 20 meters, then that takes about 3 seconds. So this is 3 seconds, and this is a little bit more than 3 seconds, about 3.5. So if you look at this question here, I think definitely this is not answered, this is not answered, and this is not answered. It's about 3 or 3.5, right? So I think from this question here, we can deduce that this is the correct answer, and therefore this is also correct answer. You get what I mean? So this is 20 meters right there. So we were sort of unsure between these two, but then this one, because of all these, because this choice here, A, B, they are not making any sense. this is the only answer, and that's telling us that instead of 3, this one must be correct, 3.5. Okay, so that's about 3.5. This is about 3. So yeah, these two questions are sort of supporting each other. Okay, so this tells you the answer for that one. This tells you the answer for this one. Okay, so that's one way of doing it. Another way of doing it is you use this equation. V squared is equal to u squared plus 2as. And you can go up here and see that like about 12 there, the velocity is 11, right? So when it reaches 20 meters, the velocity became 11 meters per second. So let's plug that in. 11 square is equal, initial velocity is 0, right? So that's 0 square plus 2a times by 20. So this is 121. So that's what 11 square is, and this is 40a. So this is giving us a is equal to 121 divided by 40. So this is about, 40 times about 3 is 120. So a is about 3 meters per second square. Now, how long does it take? So this is the average acceleration, which can help us answer this one right here. So it took at acceleration of 3. How long does it take to reach 11 meters per second? So you can use this equation here, u plus at. Final velocity is 11, initial velocity is 0, acceleration is 3 times by time. So time is equal to 11 over 3. So it's about 3 point something here, right? Isn't it? So because 9 divided by 3 is 3, and 11 divided by 3 is 12 divided by 3 is about 4. So it's about 3.7 or 6, something like that. So the answer is 3.6 right there, okay? Now, let's have a look at this one. So of the following, the distance that the runner traveled during the first 5 seconds is closest to. So the first 5 seconds. So you know that 39 and 38 sort of supported each other and helped us figure out the correct diagram. So based on this diagram, you can see that in the first 5 seconds, the answer is 40. So the answer is 40, simple as that. Okay, and let's go for this one here. In another race, the runner ran 200 meters in a straight line in 19.5 seconds. First 100 meters, his velocity changed with displacement as shown in figure 1. So, and if his acceleration was constant for the last 100 meters, the best of the following estimated velocity as he crossed the finishing line is. So what this question means is this. You have, this is now going to be a 200 meter race. Okay. So this is now a 100 meter, and I'm going to draw another line here, suggesting that this is now 200 meters. Okay, so that's 200 meters. And we know that this took 10 seconds. And it is going to take, so it's going to arrive at 200. We don't know what the final velocity is. It's going to go there, but it's going to travel the first 100 meters the same way as this one. So this took from there to there 10 seconds, and this is going to take from there to there. So I'm just going to draw some random point, and this is going to take from here to here 9.5 seconds. 9.5 seconds. All right, so whatever that is, it means it ran 100 meters in 9.5 seconds, because this whole thing is 19.5 seconds, right? So if you take 10 seconds away, that's 9.5 seconds, and it runs 100 meters in 9.5 seconds, right? 9.5 seconds. Now, you can see that the initial velocity right there, let's have a look. So initial velocity there is 11.5. Now the final velocity is, we don't know. We don't know how final velocity. So this is initial velocity now. And the final velocity is unknown. So what the question is saying is this: what must be the final velocity? So if his acceleration was constant for the last 100 meters, the best of the following estimates of his velocity as he crossed the finishing line. That's the final velocity, isn't it? Okay. So we know that the time taken, we know that so 100 meters divided by 9.5, we can think of that as the average velocity. So average velocity is total total change in displacement or distance traveled divided by time. So we know that it took 100 meters, 9.5 seconds. So whatever this average velocity is, this must be the average velocity of this one and this one, right? So 11.5 plus the final velocity. So this is a pretty difficult question, I know. So if you just take the average of this velocity and this velocity, then that will equal to this value right here. So let's give it a go. So you can see that if you multiply 2 over there, then you get 200. 200 over 9.5 equals to 11.5 plus v. So that's your answer. So you just have to figure it out. Okay, so 200 divided by 9.5 equals to minus 11.5 equals v. And I thought about using some trick to figure out, to estimate the velocity, but I couldn't really find any trick to do that. So let's actually have a look at the answer choices. So we got, so here's the thing. So whatever the average velocity is, times by 9.5 seconds. Okay, so average velocity times by 9.5 seconds must give us 100 meters. So you got to figure out what the average velocity is first. So I'm just going to divide this by this. Okay, so 100 divided by 9.5. So you can easily do this. So sometimes you just have no choice but to divide. Okay, so I'm just going to divide 1000 by 95. That's equivalent to dividing 100 by 9.5. So I think 195 can fit in here. It's 95. You can just do it really quickly. 100 minus 95 is 5. And the 0 right there, you cannot fit any of the 95 into 50, so you just have to bring in another 0. So you cannot fit in any 95 here, so put 0 there, but it's going to be now point. Now how many 95 can fit into 500? I think you can multiply 9 by 5, then you get like 45 or something, so I'm going to put 5 there, and 9 times 5 is 45, and 5 times by 5 is 25, so this is going to become 75, like that. And so it's about 10.5, okay? So the average velocity is about 10.5 meters per second. So what it means is this. The starting velocity was 11.5. And whatever the final velocity is, take halfway between these two, then you're going to get 10.5, all right? So what should that be? I think it should be 9.5. Halfway between 11.5 and 9.5 is 10.5, isn't it? So you can easily solve this algebraically as well. So like this. Then you get times this by 2, then you get 21. Then velocity is 21 minus this one, you get 9.5. So it's about 9.6, I think. So that's the answer.